You know that feeling, right? You're in an exam, you flip the page, and there it is, a question that asks you to design an algorithm. For a lot of us, our minds just go blank. But what if I told you there's a simple, repeatable method to nail these questions every single time? Well, in this explainer, we're going to break down that exact method specifically for the OCR J277 specification. Let's get into it.
Yeah, that feeling of just staring at a wall of text, trying to figure out where to even begin, it's a really common struggle. But the good news is, it's not magic, it's a skill. And there's a structured approach you can learn so that you can walk into that exam feeling confident, not scared.
So here's our game plan. We'll start by cracking the question itself. Then, we'll walk through a three-step journey. First, understanding the problem. Second, designing a solution. And third, testing and refining it. And we'll finish up by packing your exam toolkit with everything you need.
Right. First things first. Before you even think about writing a line of pseudocode or drawing a single box, you have to do the most important job of all. Fully get your head around what the question is actually asking you to do. Honestly, getting this step right makes everything that comes after it so much easier.
The secret to understanding any problem is to break it down into these three core parts. The OCR spec even specifically mentions this. Just ask yourself three simple questions. What information am I being given? That's your inputs. What do I need to do with that information? Those are your processes. And what should the final result look like? That's your output.
Let's make this super simple. Imagine the problem is, make a cup of tea. Your inputs, well, that's all the stuff you need. Tea bag, water, cup, you get the idea. The process, that's your recipe, the actual steps you follow. And the output is, of course, a lovely cup of tea. It sounds basic, I know, but this exact same logic applies to even the trickiest algorithm questions you'll face.
Okay, so you've understood the problem. You know your inputs, processes, and outputs. Now for the fun part, actually designing the solution. For your exam, you'll need to show your thinking in one of two main ways. Let's check them out.
So, you have two amazing tools in your belt, pseudocode and flowcharts. Think of pseudocode as writing out a recipe in clear, step-by-step English. It's not a real programming language, so you don't have to stress about perfect syntax. Flowcharts, on the other hand, are like a visual map of your process. They're awesome for seeing the journey from start to finish. You've got to be happy using both. And speaking of flowcharts, these symbols are your visual alphabet. The OCR spec is super clear about the ones you need to know, so you've absolutely got to learn them. The oval, that's your start and end point. The parallelogram is for your inputs and outputs. The rectangle is for any actions or sums. And the big one, the diamond, is for any decisions, those if this then that moments that create different paths. And here's that same kind of logic in pseudocode. It's so clean and simple, right? Anyone can understand it. We take an input, which is name, we do a process, joining hello with whatever that name is, and then we have an output, printing the final result. It perfectly matches that input, process, output structure we talked about. So you've designed your algorithm, you're feeling pretty pleased with yourself. It looks great, but does it actually work? And more importantly, does it work for every possible scenario the exam could throw at you? That's where this final, absolutely crucial step comes in, testing and refining. Let me introduce you to your new best friend for debugging, the trace table. This is an incredible tool. It basically lets you become the computer. You literally step through your algorithm one line at a time and keep track of what's happening to all your variables. It is, hands down, the best way to spot mistakes in your logic.
Okay, let's have a look at this example here. On the left, we've got a simple loop. Now on the right is our trace table. We've got columns for the variables and any output. See how as we go through each step of the loop, we just write down the new value in the table? By the time we get to the end, we know exactly what the algorithm did and what the final output is. It's the perfect way to prove your solution works.
The whole reason we test is to find bugs, errors. For your exam, you'll need to be able to spot and sometimes even fix two main types of errors.
Now, getting the difference here is so important. A syntax error is basically a typo or a grammar mistake, like spelling print as PRNT. The program will just crash, it won't run at all. But a logic error? Ooh, that's way sneakier. The code runs just fine, no crashes, but it doesn't do what you wanted it to. Maybe you used a greater than sign when you needed a less than sign. Your trace table is the ultimate weapon for hunting down those logic errors.
Okay, let's pull all of this together. Think of what we've just covered as a powerful, compact toolkit that you can take with you right into the exam hall. And here it is, your three-step plan for any algorithm question. 1. Understand the problem.
find the inputs, processes, and outputs. 2. Design a solution using either pseudocode or a flowchart. And 3. Test that solution with a trace table to find and fix any bugs. Just remember those 3 steps and you'll always have a clear path forward.
So, as a final recap, let's list the absolute essentials from the OCR J277 spec. You have to master the input process output method. You need to be fluent in both pseudocode and flowcharts. You must know those flowchart symbols by heart. You've got to be a pro at using trace tables. And you have to know the difference between a syntax and a logic error. And, a little pro tip, get comfortable with nesting things, like putting loops inside other loops to create more powerful logic.
So, the next time you see one of those algorithm questions, don't panic. Just remember your 3-step journey. Understand, design, and test. You have the tools, you have the method, and you absolutely have the ability to turn that scary-looking question into an easy win. You've got this.